Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 15 in our incredible new tutorial series where you're learning how to do 3D graphics and 3D animations using Vpython. What I'm going to need you guys to do is pour yourself a nice strong cup of black coffee. That is straight up black coffee. No sugar, no sweeteners, none needed. That's your go juice. Go get you some. What I'm also going to need you to do is fire up your most excellent Visual Studio Code. And as you're doing that, as always, I would like to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. Those of you who are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to do today. What we are going to do is we are going to look at the solution for the homework assignment that I gave you in lesson number 14. And that was to take that clock face that we developed in lesson number 14 and to add an animation where we had a minute hand and a hour hand going around properly synchronized. And so we want to kind of bring that clock face to life with a simulation of a minute hand and an hour hand. How many of you were successful? If you were successful, leave a comment down below saying I am legend, double chest bump, or leave a comment that you folded up like a cheap lawn chair. Actually, I'm hoping that this one was a lot easier than the last one, so I'm hoping a lot of you were able to do it. But let's go ahead and start with the code that we had left off with in lesson number 14. If you guys don't have this, go back to lesson 14. My lessons are really designed to be sequential. These are not lessons that you just jump into the middle of and just grab something. These are not hit and run lessons. This is a methodical system to teach you Python, Vpython, and 3D animations. All right, so if you don't have this code, go back to the last lesson. A lot of guys get mad because I don't just always go in and post my code like, well, let me get your code. Well, I'm not here to teach you how to copy and paste my code. I'm here to teach you how to code. And you do not learn how to code by copying and pasting my code. All right? Do we understand each other? Okay. Yeah. No copying and pasting. I want you to learn to be a programmer. All right, I will need to get out of your way here. And let's just run this puppy to make sure that we haven't broken something since last week. So I'm just going to hit the run button there. And boom, that looks like a nice clock face. All right, so now we are going to want to add some hands to that. So let's see. I'm probably going to add the hand parameters, right? We're going to do it with parameters, but I'm going to do it below these other parameters because these parameters might depend on those other parameters. They certainly should. So let's say that I have a minute hand length, minute hand L. And what should that be? Well, I think that it should be kind of like the radius of the clock face and then minus the long tick mark. And so I think I'm going to make this then, the clock radius. Let me make sure, yeah, clock R is right. And then minus, and what did I call that? That was the major tick length, minus the major tick length, like that. All right, now let's go ahead and just make that hand and just see if it looks right before we worry about animating it. And I'll make it after I put the tick marks on. So I will put it down here and I'll make it after I make the tick marks and after I make the face. So I'll come here and now I'm just going to say minute hand is equal to an arrow, and let's go ahead and give it an axis, And let's just give it an axis of, let's see, where is this thing going to be pointing? It's going to be, the face is up like this, and so I would point it out 1 in X and not up. And so that would be kind of like in the 15-minute position. So we're going to go 1 in X, 0 in Y, and 0 in Z. And I always do this. That's axis equal vector to do it, right? Okay, and let's do a color equal color dot red just to be fun. And then I don't think I have to do a position or anything like that. Now we probably are going to need another dimension besides length. Minute hand length. We're going to need minute hand, let's call it thickness. And that is, let's make that minute hand length divided by 100, just to guess. We'll see how well that looks when we run it. And then here I am going to have to remember, what is the command there? I think it's shaft width, right? So we want the shaft, is it like that? Shaft width equal minute hand thickness, like that. So we'll bring that down, and that is the shaft width. And then also we need to give a length to this, length, and that is going to be minute hand length, like that. Let's just run this crazy thing and see if we get a hand on there that looks anything. We're also going to need a minute hand offset, because if I just put it at the origin, it's going to be inside the clock face, right? So I need a minute hand offset, and that I've got to move, like if this is the clock face, I've got to have the hand out a little bit. And let's say that we are going to move it out by the thickness of the clock, by the clock thickness, okay? Because that should be all the way above it, if I am thinking right, by the clock thickness. C-L-O-C-K, thickness, like that, right? And the reason is because 0 is in the middle of the clock face, and so the top of the clock face is halfway above 0. And so then if I go a full clock thickness, I should be sitting above, you know, with a little bit of a gap in there, if I'm thinking about this right. So let's give this a try and see what happens. Boom. All right. But I did not bring that up far enough, did I? I'm still hiding down there I'm hiding down there in there. So I do not know why that did not come up. Because I didn't move it up, right? I didn't give it a position. I set it here with a parameter, but I didn't actually apply it. So I need to come down here in the minute hand and come over here. And then I need to give it a position is equal to vector. And then what direction is that? Well, this is X, this is Y, this is Z. I need to bring it out in the positive Z direction. So I will go 0, 0, comma. And what was that crazy thing that I just named that? I named it minute hand offset. So I will bring that out in the positive Z direction right here, like that. Now that should bring it out. Okay, let's look here. Let's see what happens. I didn't like that arrow. That arrow was looking kind of big and ugly. That actually looks kind of good, doesn't it? That looks kind of good. Okay. I am down in there a little bit, so I need to come up higher than that. I think I need to come up one full radius, or one full thickness of the I'm thinking. I also think that's kind of thick. I think it's kind of kludgy. So let's try to fix a couple of these problems. First of all, first problem is the clock, the hand is too heavy. It is too heavy. So I would come here to minute hand length. I thought that looked good, but the minute hand thickness, I took the minute hand length and divided by 100. I think I need to like divide by 250, let's say. And then also how high up it should be, the offset, I just put it as the clock thickness. Well, I think it needs to be the clock thickness plus the minute hand thickness, like that. And that should get it up a little bit higher there. All right, so let's give that a try, see what happens. Doesn't seem like I made that. Did I actually apply that? That is still big and clunky. That arrow is big and clunky. So did I somehow not apply that dimension? Or did I apply it incorrectly? Let me see if I can look that up real quick. Vpython arrow. Let's see if I can get something good here. I should have known this already, you know. I'll come over here. Okay, shaft width. Look at that. Shaft width did not have the underscore. And then that should also make it okay. So you see I just had a typo here, and again, I don't do all these things every day, and I have a lot of different languages that I do, and so it looks like shaft width there should have been like that. So now this might radically change things. I might need to really do things differently, but let's give that a try and see what happens. Okay, yeah, so you see now it's like way too tiny. All right, it's way too tiny. So let's see if we can fix that. Now this isn't trial and error because I'm always zeroing in because I'm using parameters. I'm just kind of just dialing it in. But I'm instead of 250, that was way too small. So I'm going to say divide by 50. And then it scales the head. Okay. I kind of like that, but still I think that's too small. But I'm liking how it's just floating above the surface there. I think that looks pretty good, although I probably don't need to be that far up there. I don't need to be that far up there. Okay, but I still think that's way too small. So I'm going to say divide by 10, and let's see what that looks like. Wow, I got way too big, way too quick. So let's go 25. Again, this is not trial and error because I'm not breaking other things. Okay, I like that. And that is up there kind of nice. It is up there a little bit too high. And so I'm going to go back and I'm going to put it half the thickness of the face plus the thickness of the arrow, and I think that will be good. So I am going to go clock radius. No, that's right, on length. On the offset, I'm going to go the clock thickness divided by 2 plus the minute hand thickness. So let's give that a try and see how that looks. Yeah, I like that. Do you see how that's now just barely, it's kind of like the arrowhead is just barely touching. It's just barely touching. All right, so now I need to make the hour hand. And so let's just come back up here and let's grab all this good stuff because that seemed to be working pretty good. And let's make an hour hand. And so this is going to be hour. And then we'll snag the hour and we'll put it here. Hour. Hour. Now the hour hand on the length, I'm just going to make it like 0.75 whatever the minute hand length was times minute hand length. And then the hour hand thickness, I'm going to leave it the same thickness as the minute hand because that looked pretty good. I think sometimes the hour hands are a little bit bigger than the middle hand, so I'm going to say on the hour hand thickness it is going to be the minute hand thickness times 1.5 because it seems like sometimes the hour hand is heavier than the minute hand. And then the offset, I think that I need to have it on up higher so that it's not just right on top of the minute hand. So we'll just take that divide by 2 off, and then let's add the hour hand thickness. Right. So you understand I'm making the new parameters based on the old parameters, and I'm just kind of winging it. And then we can dial it in after we see it. All right, let's see how that looks. Up, we better create it too, right? So I made the minute hand. Let's just snag that. And then let's paste it. And this one, though, is going to be the hour hand. And then let's see what else we need to change. This would be hour. Visual Studio acts strange when your lines get too long. It starts making it kind of hard to work with, but I want to leave my font big so you guys can see it. Let's try this hour hand offset. So that should work, I think. And do you guys see, once I make an arrow with the right parameters, then I just make another one. I think the one thing though is I better put this at a different, I don't want it on top of the other one, so I'm going to put this instead of at the 3 o'clock position, at the 15-minute position, I'm going to put it up at the 12, which would be 0 in X, and it would be 1 in Y on the axis, and that should have that baby pointing straight up, all right? Boom, I like that. I kind of like that. It's heavier. It's also floating up there, all right. I want to give it kind of a hub because you see how it sort of looks a little awkward right there. And so I'm going to kind of give it a hub so that you've got something that sort of looks like it to connect to. This is a tad bit too heavy. It's a tad bit too heavy. So let's come back, and where did we do that? The hour hand was 1.5 on thickness. Let's make it like 1.25 so it's not quite as heavy. And then let's have down here, let's just create a hub, which is going to be a sphere, and it is going to be color equal color dot red, and then the radius. So I'm just going to make a sphere there that it can kind of have things connect to. And let's make the radius the thickness of the, so let's make a new parameter. The hub radius is equal to the thickness of the clock. So let's just say clock thickness, right? Because radius, then it should come on out because The thickness is just the thickness, but the diameter is twice the radius. So that should give us something that comes out to connect to. So then radius is equal to hub radius. Hub radius, like that. All right. So let's see if that gives us a little something to grab onto there. And it's a sphere, so we really don't have to worry about its position. We want it right there in the middle. Okay. Let's look and see if that... All right. That looks pretty good. I think I need to make it a little bit bigger. I need to make it a little bit bigger. And if you don't like this, you can put something else there to connect onto it. But hub radius is equal to clock thickness times, let's say, 1.5. And that should bring it out a little bit more. Give it a little bit better chance to snag both of those hands. Oh, that's way too big. That's way too big. Okay, I think that we should also maybe what we should do is make that a cylinder. Okay, maybe we should make that a cylinder, that hub. This is getting way more complicated than what I thought it was going to be. Cylinder, and then the cylinder would be facing this way, so we've got to face it towards us in Z. And so this, I did not mean to get this complicated, but the axis would be pointing at us in Z, so it would be 0, 0, 1 pointing at us in Z, and then axis equal vector, and then the length would be equal to, let's make it 2 times the clock thickness, and that should get it out far enough to grab those two things. And the hub radius, we're still using what we were. Let's take it back to just clock thickness, and now let's see what that looks like. Okay, now that has got them both completely, right? So that looks good. It is just too fat though, right? It is too fat by about a factor of 2. And so let's make it the clock thickness divided by 2. I think that's going to be good. And then I'm going to stop fooling with it because I didn't mean to spend so much time on such a small detail. All right, I like that. I think that looks good. The two hands are on top of each other. And I think that's looking pretty good. I think that is looking pretty good. So now we've got to think about them moving, okay? And so they are going to be moving in an angle, right? We are going to be changing the direction in an angle. So we need to keep track of their position. So that's going to be 2 parameters. So there is going to be the hour hand angle, and that is going to start at 0. And then there is going to be the minute hand angle, and that is going to start at 0. And then I'm going to need the minute. I'm going to need the minute increment, and let's just say that that is how far do we want it to move every time. Let's just say 0.0001, and again, how fast it moves is going to be a combination of your increment. So I'm putting an angle increment of 0.0001 radians, and so that is how much I'm going to tick the movement each time, and I'm just making up a number, all right? And then it will be a combination of this and the rate that will control how they actually move. But what really matters is the hour increment needs to be equal to the minute increment divided by 60, so that hour hand is going to be moving 60 times slower than the minute hand, right? Because when the minute hand goes all the way around the hour hand just needs to go, one increment, if that makes sense. There's 60 minutes in an hour, so the hour hand needs to be moving 60 times slower than the minute hand. I believe that I am thinking about that right. Okay, so now we're going to come down here and we're going to see if we can animate these things. So what are we going to be changing? We're going to be changing that vector, right? We're going to be changing the vector. And so the minute hand, so first of all, let's go ahead and increment them. So hour, and what did we just do there? That was hour angle is equal to hour angle plus hour increment, right? And then the minute angle is equal to minute angle plus minute increment, like that. So that's clicking those two things forward, and the minute increment's going to be bigger than the hour increment, so they're not going to be going on the same speed. So now what is it that I actually want to change? I want to change the hour hand dot axis, right? So this is our object, the hour hand, and then I want to change this axis, which is where it is going to be pointing, and that is going to be vector, all right, is equal to vector. And do you remember who our friends are? It's Mr. Cosine and Mr. Sine. And if you don't understand this, you need to go back like 2 lessons ago. But the x value, and we're still, here's the clock, here's the vector, we're still in x and y. And so the x is what? It is the radius. And what radius are we going to be using here? We will be using hour hand length, because that is what we're doing, right? Yep, so that would be hour hand length, that's the radius of that vector, times np dot cosine times np dot cosine of hour angle, because that is the angle. And now the y is going to be that same thing, only the sine. And if you don't understand this, go back 2 lessons ago, because I explained it exhaustively. But now instead of the cosine, this one's going to be the sine. And then it is going to be 0 for the z. And I think I have a problem here with, okay, so that's the vector, hour hand, sine, and then 0. Okay, so I increment the hour angle, and then I let it run. And so let's go ahead and give it a rate here of 50. This is kind of crazy, so I have no idea if I've really thought through this enough, but I'm just incrementing the hour angle. I'm incrementing the hour angle, and I have an ugly feeling this thing's going to run backwards, but let's just see what happens. Okay, let's kill this, and let's see what happens. And nothing is moving. Okay, so now one possibility why it's not moving is I maybe am going too slow, and the other possibility is the program might have died for an error. And so I'll come back over here, and I don't see an error. Hour angle is hour angle plus hour increment. Minute angle is minute. Hour hand axis. That thing sure seemed dead, didn't it? Okay, let's say maybe we went the minute increment. Let's make it like that, just crazy. That should go crazy fast, right? That should go crazy fast. And it's still as dead as can be. No, it's not. Look, it's alive. It's alive. Look at that. It's actually going. Now, what's the bad news is? It's going backwards, right? It is going backwards. So that is the bad news. It's going backwards. But we can fix that. Because you got to see this is the positive, well, your counterclockwise is the positive direction with angles. And so what we can just do is we can fix that really simply by incrementing with a negative here. And if we increment with a negative, it should then go clockwise. Okay, so let's kill that. Let's try it. That scared me. That thing looked as dead as could be, couldn't it? There it goes. Okay, now the one thing I'm not sure of is why is it starting down here when I wanted it to start up there? Because that first axis statement, yeah, it's counting this as a 0 angle. So that makes sense, and that is moving suitably. All right, we'll fine-tune things later. And I kind of like the speed that that's going. So let's come now and let's bring to life our minute hand. So that would be a lot like our hour hand, right? So we'll copy our hour hand, and then we're going to bring our minute hand to life by just making this all minutes. So instead of hour hand, this is going to be minute hand. And did I call it min hand or minute hand? What did I call that silly thing? Minute hand. Okay. See, it's minute hand. So minute hand. And then the vector now would be the minute hand. And then instead of hour angle, that is going to be minute angle. Do you see how easy this is if you use logic when you name your variables? And then you got to kind of think on the first one, and then after that you don't hardly have to think. Watch me say that and then watch it not work. Like that. Okay, let's see if this brings it to life. Okay. Now, I've got an error in logic here because when it goes all the way around, watch this, when it goes all the way around, I went one click here. And so I think that I made a mistake. I shouldn't have divided by 60. Should I have perhaps divided by 12? There are 60 minutes in an hour. But when I go around, then I want to go 1, which I think maybe I want to divide by 12, because when the minute hand goes all the way around, I want the hour hand to go around by 1/12. So maybe, I didn't think I would have to think through this in real time, but it's either going to be divide by 12 or divide by 5. But let's see, when the one goes all the way around, then I want the other one to go around by 1/12 of that. So I think where I divided by 60, I should have divided by 12. Okay, the minute hand goes all the way around, and the hour hand goes 1/12 of the way around. So let's see if that works. I like that. Now it's going to come all the way back here, which would be 1 revolution. And I think it is going to work. Look at that. Boom. I've got those things. Is this neat or what? Look at that. We got a live clock going here. I am just loving this. But what I am not loving is now they're not synced up like a clock. I really do need to start at the 12 o'clock position. You see, I started at an angle of 0, where I should have started at an angle of pi over 2. If I'm thinking of this right. Okay, right? This is 0, this is pi over 2. I need everything to start at pi over 2. So where would I do that, right? Yeah, my hour angle, I started at 0 where it should have started at np dot pi. Our friend np dot pi divided by 2, that would be starting at the 90-degree position. And then I'll come down here, np dot pi divided by 2. I want them to both start up there. And now let's give that a try. Yeah, look at that. Look at that. Giddy up. Giddy up. Okay, so let's bring that minute, and right when it gets to the top, it should be right at, boom, that looked good. Let's let this thing run for a minute and then start thinking maybe about things we like about it and things we don't like about it. I think that's looking really good. I just want to make sure that I don't have like a round off error, that really when it hits, it should be right at the 3 o'clock. Boom, that looks really good. It's still a little confusing. It seems so right when I divided by 60, but it was divided by 12. Okay, so that looks good, and this would not be complete. This homework would not be complete, or this assignment, or this lesson would not be complete without me giving you a homework assignment, right? So what I want you to do is I want you to go away, and I want you to add a second hand, and I want you to at least approximately have it run as a clock. Like, it doesn't have to run perfectly, because you got to kind of, you might have to sort of trial and error it a little bit. You might have to sort of trial and error it a little bit. But what I want it to be is kind of like approximately. I want you to kind of run it approximately at the speed of a real clock. Okay, so if you go 1 minute, that second hand should go around in a minute. Okay, and then if you do it right, then the minute hand should work, and if you can make the second hand work, then the minute hand and the hour hand should work. Why? Because we use parameters, so you're not in there trying to calibrate the hour hand and the minute hand and the second hand. Just make the second hand work, and everything else should work properly. Okay, man, I really like this. I did not anticipate that I would like my clock as much as I like my clock. I love my clock, okay? And I like the way this is working. And look, we're going to come all the way around. Now, I want you to kind of think about something. Maybe you hadn't thought about this. Okay, but you notice how when we did a box or we did a ball bouncing around, we always, when we got to the limit, had to turn around and have it go backwards. Well, the neat thing about the sine wave, it is periodic. And so even now, the angle is not between 0 and 2 pi. It keeps going. It's going 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. But the sine and cosine functions are periodic. They repeat themselves. And so even though right now the second hand is not coming up on pi over 2, it's coming up on like 25 pi over 2 because it's gone around a lot, the sine and the cosine are periodic. And so the thing works like a charm without having to worry about what happens when you go all the way back around, if that makes sense. Okay, you guys need to go away. You need to add a second hand, and then you need to make the thing run sort of accurately like a clock, okay? All right, guys, I'm not asking you to set the clock. You can start at midnight, but you want it to just keep time from midnight properly. And I guess if you started your program running at midnight, then you could actually use it to tell time. Okay, guys, I've had a lot of fun here. If you've enjoyed this video, give me a thumbs up. If you haven't subscribed to the channel already, please subscribe. And if you subscribe, make sure you ring that bell so you'll get notifications on my future lessons. And share this with other people, because the world needs some more people that can code and fewer people sitting around watching silly cat videos. This is Paul McWhorter from TopTechBoy.com. I will talk to you guys later. Good stuff.